What is KCL? Kirchoff's current law, or KCL, defines the behavior of current in AC and DC electrical circuits. Before we get into Kirchoff's current law, we should probably start with some basics of current. Current flows through any closed circuit with voltage and resistance. In series, current is constant because there is only one path for charge to flow through, while in parallel, there are multiple paths and current is not always the same. This will be important later because Kirchoff's current law helps to calculate current in parallel and mixed series and parallel circuits. Kirchoff's current law is described by the equation sum of I in equals sum of I out and states that the sum of current into a node is equal to the sum of current exiting a node.
But what is a node?
A node is just any point on a circuit which joins two or more circuit elements together. Now that we know all of the concepts for using Kirchoff's current law, let's look at an example. Here is a section of a circuit in which a node is shown and current splits between two routes. Referring to the equation for Kirchoff's current law, we can write that the sum of current, in which in this case is the 10 amp source, is equal to the sum of current out of the node, or I2 plus 7 amps. Rearranging this equation, we get I2 equals 10 amps minus 7 amps, which equals 3 amps. This process can get a little more tricky when other elements are involved and only one or less of the current values is known. In this example, there is no known current, but using Ohm's law, the source current I1 can be calculated. After a quick bit of algebra for the total resistance, I1 is calculated to be 4.67 amps. Next, the current divider rule can be used to calculate the current I1. Now we can simply use Kirchoff's current law to find our last current value. Now we have completed our calculations and seen why Kirchoff's current law is so important for circuits. This rule is very useful because it allows for circuit solving techniques, such as nodal analysis, which can solve virtually any Ohm's law circuit. Congratulations! You know what Kirchoff's current law is and how to use it. Now you can make King Raad proud.